we're going to look at the Fenwal board. So the Fenwal board, this unit right here, is used on a few different grain dryers. And the Matthews company, MC, uses this board, and GSI uses this board. This board is a very common board. Now this one here specifically is for a GSI dryer. Now you'll see on the ignition coil right here, it says ignition time 4 seconds. So this has a 4-second delay from when you put power to it. There's a 4-second purge time. Here it's called ignition time, but I would call it the purge time. So on here, you're going to see you have a not connected first terminal. You have a V1, your next terminal. You have an L2, next V2, L1, B ground, S1, and then FC plus and FC minus. And then right on top of here, you have your ignition transformer, your wire to go to your ignition transformer. So this is the board we're talking about, but we're going to look at the manual on how this board works and how it's to be wired. So here we have the manual. Now, on the manual, we have L1 and L2. And if you trace these wires, they go back to L1 and L2. 120 degree thermostat or control device for turning on and off. This might be the computer on your dryer or whatever controls this. This is a generic wiring for that board. So when we look here, we need 120 volt on this wire. We need neutral here. So neutral connects to L2. 120 volt connects to L1. Then we have the main valve, your gas valve. The one side of that connects to V1 and the other side connects to V2. This is all simple wiring. Most people don't get this goofed up. This switch kicks, this is internals of the board. This kicks on and off to turn your board on and off, to turn your gas on and off, which goes out the V1 here to the valve. So that's your switch that the board turns on and off. Now, what turns that switch on and off is one thing. If the board is working properly, only one thing. So we have S1. S1 is the flame sensor. That goes down here and goes to the sensor that is in the flame to monitor the flame. It puts voltage into that rod, wire and rod, and draws milliamps through the flame to ground. Now the burner is connected to burner ground. The burner, the housing, right here we have the ignition igniter. So off this coil, we have a wire that comes out here. It's high voltage out. It goes out here and it's your ignition. Your other probe that arcs off of comes back and is connected to the ground. And that all connects to burner ground, to B ground on the board. So B ground connects to your housing of your electrical panel, your igniter probe, and your burner itself. They all need to be bonded together. And then here we have the igniter, which goes and arcs off of ground. And then up here we have our L1, L2, V1, V2. Like that's all there. It's quite simple. So now that we understand the wiring, we're going to look at how it works and what causes how the physics of the board work. So when you put power, when you close the switch and power go 110 VAC goes to L1 and neutral on L2. You're going to have the ignition time. You put power there and nothing is going to happen for however long the ignition time is. So on here it's 4 seconds. So we put power to L1 and neutral to L2. And after 4 seconds, this switch closes and it puts electric out V1. So V2 is connected to L2. And that's all connected. We have this connected with a resistor. So after 4 seconds, this switch closes. It puts electric out to the main gas valve. And it puts high voltage out the ignition transformer to arc off the ground. So this is going to spark to make it light. This turns to get V1 turns the gas on. Our high voltage makes the spark to make the burner light. If you don't get any electric out V1 after the ignition time is complete, S1 is your sensor. If this sensor wire or probe is grounded out at all, meaning damp dirt on it, cracked porcelain, a wire rubbing somewhere, mice chewed on a wire, if that wire is shorted out anywhere, you put power to L1 and L2 and it will not put power out V1 and V2. You will not, if S1 is shorted to ground at all, you will get 0 voltage out V1. Because this will not close. It'll say we have a problem with our flame sensing. So if we disconnect S1, disconnect the wire from S1, and we put 120 volts to L1 and L2 after the ignition time, this switch should close and we should get voltage out, V1, to power the main gas valve and spark. If we have the S1 disconnected and we put power here and we do not get power out, there is a problem. So at that point, we need to look at, is our voltage correct? Is L2 neutral? Is L1 115 volts? What's the difference in voltage between L2 and your ground? What is the difference between L1 and L2? Because we need 115 volts. If you have 90 volts, it's not going to work. If you have 180 volts, it's not going to work. If we know our incoming voltage is correct, and we disconnect S1, and we turn the voltage off and back on the L1 and L2, or 120 volts, and we have S disconnected, and we do not get power out V1 and V2, 120 volts AC on V1 and V2, we have a bad board. Because the S1 wire is the only thing that controls this board. Incoming power and S1. Only two things. If S1 is not connected to anything and we put 120 volts to L1 and L2, we should get 120 volts on V1 and V2 after ignition time. But when we get voltage on V1 and V2, it will only be for a limited amount of time. It will only be for maybe 7 seconds or 10 seconds, depending on the board. So it's going to be a limited amount of time. And then if it does not ignite and see flame sensing on S1, it will turn off. Or if you have S1 disconnected, it may ignite, but it's still going to turn off because the board didn't know it ignited. So that's how the Fenwal board works. They're a very simple board, and some people use them at times to replace other brands of boards. That's about all there is to it. They're a very simple board. On here, I've used them with anywhere from 4 to 30 seconds for your purge time, depending on the burner or depending on the application. And that right there is the wiring diagram that you need to look at, because that's how things need to be wired. I've seen it where S1 is connected to the ground probe here. That will burn out boards, because arcing off the sensor wire is going to burn out the board eventually. There's a lot of different configurations of wiring I've seen, but this is the correct way to wire your Fenwal board in your GSI or MC dryer. Now, one other thing, V1, it shows V1 going straight from the board to the main valve. I would recommend having a 3 amp fuse, a 2 or a 3 amp fuse on the V1 terminal, between V1 and your valve. Because if that valve shorts out, I've seen it, if that valve shorts out, it can fry the board. So if you put a fuse on V1, it will extend the life of your board. It'll last longer.